Hello, my name is Igor Zavalyshyn. I will be presenting a paper called Building Private by Design IoT Systems. So IoT devices are now everywhere, on your wrist, in your living room, and even in your city. And there are plenty of IoT systems and platforms allowing you to control those devices and benefit from hundreds of third-party applications. The problem of those systems, however, is that the user data is usually in risk. This is because systems and platforms use obscure data handling techniques in which users and the owners of the devices have little to no control over the data, and the applications that the systems provide are usually overprivileged, and they can access and do whatever they want with the device data without user awareness. So in order to prevent that, we propose to build private by design IoT systems in which users have exclusive data ownership and can enforce their privacy policy expectations and preferences. We provide 3 building blocks in order to achieve those goals. We will go through all of this in details now. So first is element-based programming model. What it means is that we grab the application and represent its logic as a graph of elements. And we illustrate this with a simple application called Watch My House. What it does, it grabs the images from the IP camera and sends them to the user-specified cloud storage, for instance, Dropbox. So if we want to represent that application logic as a graph of elements, we split it in 3 elements. The first one will be grabbing the images from the camera. The second one will be preparing the HTTP request payload, the image in it. And the third one will be actually making the HTTP request to the Dropbox service. As you can see, there are only 3 elements and 2 edges connecting them. And the edges in this case represent data flows within that application. So by having this graph, we can make the data flows inside this application explicit. And this helps with verification of the application logic. So in order for the users to specify their privacy expectations regarding the data processing, we designed an interface for the users in which users can specify which data flow they want to allow or block in their respective smart homes or IoT setups. So first they select the rule type, which is allow or block, then they select the data source, in this case it's living room camera, then the data type, image, and the data sink, where the data flows to, in this case Dropbox. Optionally, the users can specify time restrictions. Now we have a data flow graph of application, we have a user-specified data flow rule. Now the only thing missing is the mechanism to enforce the privacy policy of the user and verify the data flows inside application. So what it will do, it will grab the application graph and detect the source of data, which in this case is IP camera, the data type of the data flows, it's image, and the sink, Dropbox. Based on that, it will allow that application to execute during a certain time of the day. If there was another application trying to leak camera images, for instance, fake cam, to camspy.com, it will do the same thing with this application as with the previous one. It will detect the source, IP camera, data type, image, sink camspy.com, and it will block that application because it violates the policy of the user. Now, using these 3 building blocks, we developed 3 systems that span across 3 domains: home, cloud, and mobile. The first one is HomePad. It's a private smart home hub. It provides a model in which the data is processed locally without necessarily sending it to the cloud for processing. It employs element-based application programming model and provides a rich set of built-in API elements for application developers to build their applications and services, and also drivers for smart home devices. The Patriot is a private by design platform. It's a fully fledged platform for IoT. It is securely running inside SGX and clouds, which protect the data inside of it and the computation. It provides a UI for the user to control the devices, specify the privacy expectations and preferences, and also install applications. And provides a mechanism for enforcing the privacy policy of the user. And the cool thing, it comes as a Docker image, so anyone can install it on their own private server or on some public cloud infrastructure with SGX support. Finally, we extend the dataflow model to mobile environment and allow to use the same approach with element-based programming when building Android applications. And it can be beneficial for both users and application developers to clearly separate the data flows inside their applications. And it requires no changes to the Android whatsoever. So as takeaways points, I will just remind that we propose the IoT systems that are private by design. It provides fine-grained data flow control. It's beneficial for both consumers, IoT developers, and services. And it's completely open source and extendable. Thank you.